Now we're going to talk about mid-segments in a trapezoid. A mid-segment in a trapezoid is this segment that you see here. That segment that you see here. That segment will bisect the legs. Okay? This point here is the midpoint of this leg, and this point here, point N, is the midpoint of this leg, and it bisects the leg. Okay? And so that means that this leg is congruent. This piece is congruent to this piece of the leg because we just cut it right in half. This is the midpoint of the whole leg. And also over here, this point here cuts this leg right in half. So this piece will be congruent to this piece. Okay? And the mid segment is also a segment that is parallel to the bases. Notice how it's parallel to the bases. Okay? Here, formally, it says that the mid segment is a segment that connects the midpoints of its legs. So I have the midpoint, I have the midpoint of this leg, which is here, connecting with the midpoint of this leg, which is here. There it is. That's your mid segment. And it's parallel to the bases. Okay? Now, we're going to be interested in finding how much the mid segment measures. And one way to do that is with this formula. The formula says it's segment AD plus segment BC. That means this segment, whatever that measures, plus this one, and then we divide that in half. And that's how we find the measure of the mid segment. Let's see an example. Here's a trapezoid. It tells me find the length of the mid segment DG of this trapezoid. Here's the mid segment. I have to find the measure. Now we already know that the mid segment is the connection of the midpoints of the legs. Okay? We also know that it's parallel to the bases. And to find the measure of the mid segment, the formula says that DG is equal to a half of the bases, the sum of the bases. So I add CH, which is one of my bases, this one here, CH, plus EF, EF. Those are the two bases. Okay, so DG will equal a half of that sum. CH is 20, EF is 8. So this is equal to a half of 28, which is 14. Your mid segment measures 14. Let's see another example. Find the length of the mid segment MN. Okay, let's do number 4 first. Here's my mid segment MN. Very simple. What you do is MN is equal to a half of the sum of the bases. My base measures 14, the other base measures 8. How do I know which are my bases? The bases are the parallel sides, okay? So this equals a half of 22, which is 11. There you go. For this example, notice that my trapezoid, the bases, remember, are the parallel sides. Here's one parallel side, here's the other parallel side, so these are the bases. So to find MN, MN is equal to half of the sum of the bases. I add the two bases, and half of that is the mid segment. That's 8. For this example, my bases are 24 and 18. Mid segment MN is equal to half of the addition of the bases. That equals a half of 40 2, which is 21. Okay, and that's how you find mid-segments. Now, here's one with a little bit of algebra. Let's do number 41 first. If QR is 16, QR is this base, 16, and PM is 12, PM is 12. They're talking about the mid-segment. And TS is 4x. This is 4x. That's the other base. How do I know this is the base? Because that's the parallel sides. Okay. Find x. So this is what we do for number 41. I know what the formula is for mid-segment, and I know what the mid-segment measures. I know that 12 came out of adding this base plus this base and dividing it by 2, and I got 12. Okay, so let's write that statement. I know that PM is equal to a half of adding the bases, like we learned in the previous example. I also know what PM is, so I'm going to substitute PM for the value of PM, which is 12. And from this point on, this is algebra. I have a half outside of this parentheses, which has a sum. So I need to use my distributive property, okay? Or I can write this like this. This is equal to 16 plus 4x divided by 2. This 1/2 is the same thing as saying half of whatever that sum is, okay? And now we can use algebra, and to do that we can cross multiply here, or multiply both sides by 2. I can multiply this side by 2 and this side by 2, and that will cancel out this 2, and 2 times 12 is 24 equals 16 plus 4x. Now I want to solve for x, so I get rid of this 16 that's next to the x by subtracting 16 on both sides, and you get that 4x is equal to 8. And now we can solve for x by dividing by 4 on both sides, and we get that x is equal to 2. And by the symmetrical property, this is the same thing as writing x equal to 2. X equals 2, that means that TS equals 8, right? 4 times x. If x is 2, then this is 8. So I can check and add 8 plus 16 and divide it by 2 and see if I get 12, like I'm supposed to, right? So 8 plus 16, that makes 24, and 24 divided by 2 gives you 12. So this checks out. Okay, so notice here that you need a lot of algebra. This step here, I hope you didn't get confused. Another way to do this step, I'm going to show you over here. Another way to do that step is if I have 12 is equal to 1/2 of 16 plus 4x, I can use the distributive property and multiply 1/2 times 16 and then multiply 1/2 times 4x. Let's do that. 12 is equal to 1/2 times 16. That means half of 16, which is 8. Plus 1/2 of 4x. So if you have 4 x's and now you're doing 1/2 of that, that means you have 2 x's. Okay? This is what it looks like. It looks like 16 over 2 plus 4x over 2. 16 over 2 is 8, and 4x over 2 is 2x. And now you can subtract 8 from each side of the equal sign. 12 minus 8 is 4, equals 2x, and you divide by 2 on both sides, and you get that x is equal to 2. You get the same result, okay? So I hope this isn't confusing for you, and I hope you understood this example. You have numbers 42, 43, and 44, which you can try on your own, and you can bring them to class, and we'll discuss them in class.